Hello, my name is Yulissa, and today I'll be presenting my freestanding project of the abdomen. As you can see here, my project is made out of styrofoam, some pipe cleaners that were curled up into a more circular structure, a wooden base, along with some wooden tubes to hold the project, along with some various glues and paints to ensure that it's the best visibility and to maintain the model standing. And starting off, we start off with the inferior vena cava, or the IVC for short. Starting down from the distal location from the top, because the IVC drains into the heart, we start off with the internal and the external iliac veins specifically. These iliacs drain from the lower limbs and enters into the common iliac vein. The common iliac vein then drains into the central IVC. The IVC then goes up until we reach the renal veins. The renal veins, or the kidney veins, if you much prefer, are connected to the kidneys themselves, where you could see them drain the kidneys. And while the behind model provides a better view of the veins. As you can see, the right is way shorter than the left due its proximal location to the IVC. Then we could see from how the left renal vein is much farther, where it goes behind the organs, however, it goes in front of the aorta and behind the SMA, or the superior mesenteric artery, which then drains the left kidney. Moving slightly up, but it's detached from the IVC, we can see the SMV, the superior mesenteric vein. This superior mesenteric vein drains the small and large intestines. And as it goes up, it becomes a portal confluence with the splenic vein. The splenic vein goes underneath the pancreas and enters the spleen, where it drains blood from the spleen that then meets the SMV, that becomes the portal confluence, and then goes behind the pancreas to then drain upwards towards to become the portal vein to enter the liver hilum, as you can see here in this small little vein. Going back to the IVC, we go upwards until we reach the upper portion of the liver, where we can see, for a better demonstration, the right, middle, and left hepatic veins that enter the IVC. Moving on to the aorta. As we move to the aorta, we could see where it goes down, because it's coming from the heart, the celiac axis. And the celiac axis, it's not visualized very well. However, we have three central veins where it's shown where the celiac axis originates. In the celiac axis, we have the left gastric vein, where it goes around the lesser curvature of the stomach and enters the hepatic artery, another main branch of the celiac axis, as it goes from the celiac axis to the liver. Then we have the splenic vein, which goes behind the stomach, and then anterior to the pancreas, and on top, superior to the pancreas, where it enters the spleen. Moving along, we have the IVC, the aorta, I'm sorry, we have the SMA, the superior mesenteric artery, which runs parallel with the aorta and entering the intestines to supply blood. We also have the renal arteries, which is more appreciated in the back. We have the left renal artery, which is shorter because it's closer in proximity, and we have the right renal artery, which goes from the aorta behind the IVC to enter the right renal. Then we move down where we reach the common iliac artery with its internal and external subdivisions. Now that we have known the incredible vessels of the abdomen, now we can move on to the organs. These organs are specific and provide essential functions for the body, such as the liver. The liver provides countless to hundreds of functions, including metabolizing carbohydrates, proteins, and fats, along with producing bile. It detoxifies the body, along with being a blood reservoir, to name a few of its functions. Then we move on to its gallbladder. The gallbladder stores bile from the liver and then secretes it into the duodenum when the body requires it, which is when there's fats in the body and being digested. Moving on, we have the stomach. The stomach physically and chemically breaks down food that we intake to then be produced into a smaller component so the body can digest it better. Moving into the pancreas has exocrine and endocrine functions. Endocrine in regulating blood glucose levels, and exocrine in producing blood digestive enzymes that then secrete into the small intestine and the duodenum to help break down food. We have the spleen, where it's a major component and for our immune system, where has adaptive immunity and produces antibodies for us. And it also filters the blood along with acting as a blood reservoir similar to the liver in cases of extreme blood loss. Then we can move along to the kidneys. As you can see here, the kidneys filter the blood. They filter the blood, remove toxins, and make sure our body is clean to ensure continue functioning. Then we can move along to the small and large intestine. Included in the small intestine is the duodenum. And the small intestine, continues to break down food chemically, along with absorbing the necessary nutrients. And the large intestine absorbs water along with some vitamins and some vitamins and other necessary nutrients and then combines all the solid waste to create it into feces that then is later excreted. From this project, I have learned a lot because I've struggled quite a bit with understanding where the locations of certain organs and their arteries and veins specifically, specifically more the renals because they're so intercrossed with each other. So making this model really helped me in understanding where things go, along with the visualization of how the body is going to look. So when I'm scanning, I understand where everything is. Aside from that, it also helps me learn how the functions of each of its specific organs. Thank you for listening.